I'm speaking with Mr. Cyriac Kottoor, a retired actuary with more than 34 years of actuarial experience in life and health insurance industry. He most recently worked for General Reinsurance Company as an actuarial vice president.
Yeah, the actuarial science is used primarily in the insurance business. If you think about a product, who sets the premium, who makes sure that there is enough money to pay the claims, we are responsible to do all those calculations. And you require some amount of mathematics, but it is not just mathematics. It's also business, it's also law, it's also accounting, it's also computer knowledge. So you need a whole bunch of things to come together. My last project that I did for Gen Re was developing a critical insurance product. Mm-hmm. Critical insurance product basically pays a lump sum amount to the insured, if they get sick. So it can be a cancer, it can be a heart attack, it can be a stroke or kidney failure, any one of these. So when I wanted to price this product, I needed a lot of information. I needed the incidence rates, meaning how many people get heart attack in a given year per 1,000. So maybe 5, maybe 10, maybe 100, I don't know. Then we need to know the survival rate of the people. We need interest rate, we need expenses, we need profit objective. All these different things we need because when you want to set the premium in such a way that there is enough money there to pay the claim, enough money there to absorb all the expenses like commissions to the agent, salary for the actuaries or the other people in the company, the building, and all those things has to be paid by somebody. And then, of course, the management who invest money into this, they want to get a profit, a reasonable profit for it. So we went and got the data from American Heart Association. There's a lot of information, and we have to siphon through it. Sometimes we had to interpolate, sometimes we had to smooth. Things like that is done, or if there is some abnormality in some cells, it has to be explained. I mean, we can't ignore it. So you have to calculate a whole bunch of premiums for all these people, and you use these premiums, put into it, and see what that premium does. How much income is it going to bring into your company, and how much is your expenses based on your assumptions? How much profit are you going to get? And then you can actually see what is going to happen if it played out the way we think it is. Sometimes there are certain minimum amount of sales required to break even because of your expenses or fixed expenses. That's the beginning of the discussion phase. Then you do all this what if analysis. You change the sales assumptions. So sometimes you would say, okay, you have to at least sell 1 million policies to, make a reasonable profit or make this project worthwhile. When you have several factors into your model, you can adjust one or two at the same time and see what all this things happening. And right. It's interesting that some things that you don't expect happens. And then you go back and look, is it a problem with the model, or is it a problem with our thinking? So you tell them what you think and you explain it to them. That's another interesting part of your life job as an actuary. So you get to explain a lot of these things, which are, pretty just numbers in front of you, with some labels. And if you're able to explain why something is not the way it is or as expected, that's your job. You solve complicated problems, you answer difficult questions through mathematics.
How do you think it's going to change in the next, let's say 15 to 20 years? And
the actuaries are going to be valuable and needed, even if there's advances in computing. But their scope of what they do does not change, but the way they do it probably will change. So they may not be crunching all the numbers all the time. So there will be more time for people to think and work through problems and figure out formulas and answer questions.